Hello friends, welcome to the last session of the data science course. So here we are going to see a project development application. Okay, you might have seen this particular data of in the first presentation, and now in the last presentation also I'll be showing the same, that is data science workflow. So when we are going to design a project in data science, so we need to focus on few points. 6 steps are there. All 6 steps we have completed. Many small subtopics are covered, many things that you might have heard for first time, many things applications might not be known, but we are going to see these steps. We are going to see the applications of all together here in the data science workflow. So we have to understand the business first. For which business we are going to create the data science project, that's business understanding. Then what data it internally contains, that we have to implement. Then data importing, you have to read this data into the project. Then you have to clean the data, manipulate the data. So many operations that we have seen, they are coming under data cleaning and manipulation. And then we are going to build the model of machine learning. There's also many algorithms we have seen. So basically most of the things that we have seen under the data cleaning, manipulation and statistical modeling and machine learning. Okay, they are the two main core part of a data science project. And finally we are having a prediction, reporting and visualizations. So visualization will be containing the user interface, where user can interact with the particular project, and then based on that we are going to make the design of it. So let's start with this. My project idea is very simple. I am having a data set with me, so let's see, we'll understand that how exactly the data science project is built and created. See, so my simple design will be based on the wine classification data sets. So let's see this file we have already seen in one of the project, one of the application design, wine class.csv. We have not achieved the reasonable accuracy over there, but now I'm going to make use of this data set, and based on that I'm going to create an application, one design which will predict the class of the wine. So this data set is available online. It's containing the classification of the wine. So some properties of the wine are given over here. You can see the first is a class of the wine, and remaining many columns, 14-15 columns are present, which shows the properties of the respective wine. So based on these properties we are going to define the class of it. Okay, so these are the class. Almost 178 entries are present and 3 classes are there. So my task will be there. I'm going to design a project of data science by which we are going to input these all values to it, and we are going to predict what is the class of this wine, but I must have the perfect output out of it, not a single changes. Means I require 100% accuracy out of it. But you might have seen 100% accuracy is not achieved in any of the project till this, but if you think from almost all point of view of the data science, it's possible to achieve the 100% accuracy also. So your accurate results can be predicted from there. So let's look at this. The things that we have seen throughout the course are like, we have seen starting from Python programming, then we have done pre-processing, visualization, feature extraction, machine learning techniques. We have seen classification, clustering, association rule, semi-supervised learning, dimensionality reductions, outliers, neural networks, ensembling, recommender systems, resampling, correlation technique, cross-validation technique, regularization. We have seen pipelining also, then natural language processing, time series, genetic algorithm, lot many things that we have seen in all. Okay, so first thing is that when a problem statement comes to you, you need to decide what kind of project is that. Basically there are 7 different kind of problem algorithms are available here in it. So if you go to this, see, classification algorithm, the first one, when the output variable expected from your project is a categorical, that time we are going to make use of this. Again under it 7 algorithms are present. Out of it anyone can be chosen. If your output is continuous, that time we are going to make use of the regression algorithm, and almost 6 more algorithms are coming under this category. Out of it anything can be chosen. Clustering, when you are going to create the group of the data, that time we are going to make use of clustering. So 3 clustering technique that we have seen here in it. Then association rule algorithms, where we are going to make use of the things like if this then that. So these suggestion based systems are created by association rule mining. Then we have seen the semi supervised learning. In semi supervised learning we are going to make use of combination of supervised and unsupervised. Means some classes are missed, so these unnamed labels are given labels with the original data which is containing the labels there. That's what semi-supervised learning is present, the fifth kind of algorithms. Then we are having the recommender systems. Recommender systems, so from the previous data, if you want to see, give some recommendation to the users from based on his searches, his purchases, so we are going to make a recommender system. So if such kind of data projects are present, that time we are going to make use of the recommender systems there. And then the last one is the time series analysis. So we are going to make use of the data which is based on the time, means that output is changing according to the time. In that case, we are going to make use of the time series prediction, because the prediction of the future data will be present with the help of the time series. Even we have seen regular genetic algorithms also. Genetic algorithms are basically they evolve according to the generations, and out of all identify the most suitable algorithm which will characterize your data. So, that is the very base technique by which you can find the effective algorithm suitable for your data. That can also be chosen. Even natural language processing, this concept also we have seen, it's required only when we are having the data in non-structured format. So we have to convert that in structured format, or you have to do some basic processing operation, language processing operation onto it, so that the data will be available for us to use in a machine learning algorithm. That's why NLP is required. Apart from that, many things are present over there. Now these things, how I am going to make use of it in my system, because as I have already shown the data to you, so data is coming under the classification category, and this classification category data set, okay, so I'm going to make use of some algorithms. I can make use of that all 6-7 algorithms, or I can make use of the ensemble technique by which we can find the perfect output or perfect predictions out of my project here. Okay, so let's go one by one according to workflow. So this is your data set. These are the chemical properties of the wine, all the inputs, and this is your output variable class. So I am going to create a design, one graphical user interface. Based on that interface, we have to give these inputs to the particular project, and it will identify what is the class of this wine. Okay, what is the class of this wine based on this data? So what other operations are expected to make your algorithm, make your project more effective, that we are going to see. We are going to have the deployment of project as well as graphical user interface design of this project also. I am giving this code with you, so you can understand, you can make the changes as per your requirement and then perform the operations accordingly. So let's see how to design this. First of all, I'll analyze my project perfectly, and after data analysis is done, then only I'm going to make use of this particular data in my program. So let's see this one. So first of all, we need to import all the packages required for our project. So I'm using pandas, numpy and seaborn for this. So let's import that. They are imported. Now my main operation to read the data set. Okay, so I'm using pd.read_csv, read your data set. So which is most important part. Your data can be in Excel format, can be CSV, can be JSON, can be data format, but all this data we can read easily in your project in the form of a data frame also. So let's read this one and check the size of it. 178 rows and 14 columns are present. Okay, you can check the data is correctly created, so that's how it's possible. And now I'm using minimum and maximum function. There's a special reason why I'm using this one, because when I'm applying some algorithms like k nearest neighbor, support vector machine, or new base, or the logistic regression, this algorithm require the data to get scaled down, because the high features, the feature with high ranges can affect the output. That's why it is required to find the minimum maximum. So you can check it out, all the minimum maximum values, all their ranges are different. It means that when any one of these algorithm expected, so that time I require to scale down this data or scale the data in the same ranges. Okay, so you can check it out, all of these ranges are different. Now first I need to check whether the missing value is present there or not. Now missing values, we have seen this, we can check with the help of isNull.sum if any missing value is there or not. So you just can check it out, is null if anything is missing. So their addition I am doing over here and then I am showing it. So see, you can check it out. Magnesium 3 values are missing, view 2 values are missing, and OD 283 15 contains 7 values missing over there. So if these values are missing, I need to apply some criteria to replace these values or to clean that values. So here I am applying the criteria to replace the median instead of these values. Okay, so this one, data of magnesium, data dot replace, wherever nan is present, they replace this data by median of the remaining values. Similar to that I am doing for UE also, I am doing for this OD 280 and OD 315 diluted wines also. So I have cleaned this data. So remember, any of the method can be applied. For data cleaning, we have seen mean, median, mode. Mode is required only when string data is present, and we can make use of imputer class also to clean this data. But it's depends. So you just try all of these methods, which one is better, that can be identified. And now check the sum of all. So now see, all are 0, nothing is missed, and we are going to have the perfect clean data out of it. Now main part, that is to decide the input and output variables. Input and output variables, basically when the project comes to you, output is expected by the client, is decided, it's driven, and most of the time output is already known, but by logic also you can identify what can be the possibilities, what is your dependent variable, what is your independent variable. So for this case we know that class is the dependent variable, means you are defining the output variable as a class. So class 1, class 2 or class 3, any one of these class can be defined. So I am dropping class and remaining all this my input, and output is y. We can check how many possibilities are there in the output. So here we visualize this one, SNS dot count plot y. So how many possibilities are there? 1 are almost 58, 59, 2 classes are almost more than 70, and third number 3 is almost 40 to 50. Okay, so 3 classes are present over there. So in this way we can find it. Or if you want to see the let's see, head of the x, how many columns x contains and what are the properties present over there, we can see by this method. Okay, so all of their numerical properties are there. So it means you don't require to encode the data. So one hot encoding or label binarization, which is not expected over here in this. Okay, so we can check this out now. Or even one more method that we can see, that is called as info. So you can check this out. Info, it will show the information about all. So all are numerical columns, you can check it out. This all are float, the last is integer only, all are float. That's why we don't require any encoding methods over there. Now let's perform the operation of the feature selection. Now out of all the 14 features which are given as input, is it expected to use these 14 features? What do you think? The total 13 columns are there, 14 is the output, 13 column. So can we take all? So maybe all are not expected. I will focus on feature selection more, because it will reduce the time required for prediction, time required for the classification also. So first of all I will find a duplicated values. Now as we have seen this concept already in feature selection, I am just making the transpose of this data. So rows will become column, column will become rows, and now I am going to delete the duplicated rows. So how many duplicated rows are there? You can check this out. So xt dot duplicated dot sum, so total duplicated rows are 2. Okay, 2 rows are present which are duplicated over here. So we can duplicate duplicated rows can be deleted by this method, unique features equal to xt dot drop duplicates, keep the first and then transpose. So again original data set will be getting over here. Okay, so we just can check this. Now unique features I am keeping into x variable, and now let's see the data 11. So 2 duplicated rows are deleted out of it, and we are going to have only 11 columns now. So this is transposed after duplication, it's removed, transposed. Okay, so 2 duplicated rows are already deleted from there. Okay, so your data is now containing only 11 features here. Now we can find a correlation also. So first of all created a set for correlated features, and after using Pearson correlation I have created the correlation matrix over here. So you can check it out, correlation matrix, class against other, their correlation can also be found. If correlation is very low, in that case that particular entry can be discarded easily. So you can check it out, class against other, this particular or this particular thing. So see, minus, this is plus, okay, ash, this is very low, only 4% effect is there of ash, very minus 4%. So this is also, this magnesium is 100% affecting, hue is affecting, this code is affecting. Okay, let others also check. Everyone is almost affecting the class. such as correlation by Pearson correlation we have seen. Even we can use the method here as the Spearman correlation, that's also possible. And check the Spearman correlation also. See, Spearman correlations are just like this. Here also very low correlation factor is shown. Others are also present. See, many of them are very good in defining. This is 100% correlated. That's why they are having good effect in the output. Fine. Okay, so for that purpose, ASH is having very lowest impact, this correlation. That's why I am deleting it. Remove uncorrelated features. Okay, so delete that, and now we are remained with the 10 features only. Okay, so now 10 features are available, 178 rows are there. Again, from 10 I can select the top 5 features which will perfectly classify my data. So for that purpose I am using the select k based. Okay, select k based. Many more are also present. You can use constant features, we can use quasi constant features, we can use RFE also, but it depends upon your trial and error methods. I will be making use of select k based here. Okay, from select k based class I am importing, and then Chi2 square as we already seen. Then I am creating the object of this, k equal to 5. 5 features are required out of it. Then feed that data, transform it, and see the top 5 features present over here. These are the top 5 features present, and their names are not available here because the data is in array format, that's why. But I can identify this column is alkalinity of ash, this column is the magnesium, okay. Then this column is flavonoids, this one, this is color intensity, and this is proline. So these are the top 5 columns which are affecting the output finally, which are extracted from there. So for that purpose, what I have done, I am just taking these 5 columns, okay, this column names in variable calls, and only that columns I am extracting from the X. Okay, only that columns I am extracting from the X. So if you want to see this X here, so see, only 5 columns are extracted which are affecting the output, which are affecting the final output. You can check it out. Okay, only 5: alkalinity of ash, magnesium, flavonoids, color intensity, and proline. Fine. Okay, so my feature selection is done. Now I want to check whether any outliers are present there or not. So for outlier detection, we are having box plot method, box plot trimming method, or the scaling is also present, clustering is there, isolation forest is there, one class SVM is there. So out of all I have chosen isolation forest. You can try others also, but here I am using isolation forest. Okay, as we have seen effect of outliers. So outlier removal is very important part over here. Create the object of it, fit it, and predict it. So it will this clean will predict the wanted features and unwanted features. So wanted features are 1, unwanted features are -1. So I am taking only wanted features which are clean data, X and Y, and then see the shape. So out of 1, how many are there? 178. Okay, after 178 I am taking 143. Remaining features are outliers, they are discarded. So outlier removal is done perfectly, and now my data will be somewhat more cleaned. Now one important thing that we have observed already here, that your count plot. Now check it out. See this. So data is imbalanced. My output variables, my output classes, their groups are imbalanced completely. So 1 is almost 43 to 44, 2 is above 60, and 3 is almost 20 to 30. So data is imbalanced. I need to perform operations of handling imbalanced data sets. So as we have seen already, imblearn.oversampling, I am reading random oversampler. SMOD is not required, you can try that also. But here I am using random oversampler. So I will do oversampling so that all the classes in the data will be having same number of outputs there, so that my effectiveness in the output will be good, and that will be correct in generating more accurate results over there. Okay, so what I have done, let's create the object of random oversampler, random set 0, then fit it X and Y, create the resample data set, and convert them into the format of resample data. Okay, so let's go for this. Yes. Okay, so sampled. Now let's check it. Now from 143 they have gone to 198. Okay, so we have got 198 total features, total rows present, 5 features are there. And now let's see this one. You can check it out. All they are now equal. 198 features are now converted into this format. So 1, 2 and 3 all classes are almost equal there, so their impact in the output will be same. And if you see the head, see this one, this is X. Fine. Okay, so this is how we have done the resampling of the data. So other algorithm can also be chosen. It depends upon your logic again. Now scaling. So remember, all the features are having different ranges. See the range of this or this and this, they are completely different. So whenever I am using an algorithm which is having distance formulas, probability studies inside it, then it will one feature will be dominating in that case. So to remove that dominations of the feature, we are going to pre-process the data. So for pre-processing, we are having standard scaler and min max scaler. Any one of that can be chosen. Here I have chosen the standard scaler. So we will scale the data, import the standard scaler, create the object of it, and then fit transform. So your data will be scaled with the same range. So what we are doing here, we are making the standard deviation of the whole data to same. Okay, so your data is scaled now, and we are getting the scaled data, which so impact of every variable, every feature in the output will be same in this particular case. Okay, so data is scaled now. So see, so many features we applied, so many steps we required, we have applied, and we are making your data perfectly available for our next data set. Now let's come with the cross validation. So we have to validate the data. So to validate the data, validation of the data, we are performing multiple operations like train test split, k-fold cross validation, then loose CV, that leave one out cross validation, or we can make use of stratified k-fold. Any one of these can be chosen. Here I have chosen train test split. Commonly k-fold can also be chosen, so we can find that whether data is valid for the perfect this data set or not. Anyone we can make use of. Even we can see the cross validation score also. So which is the most effective algorithm to work on the cross validation for this data, that also we can use. But I am using train test split here. Okay, so sklearn.model selection, import train test split. So it's imported, and now let's split your data into two formats. So here I am using the scaled X. Output scale is not required, it's kept as it is. S is scaled. Okay, so scaled, and now let's see the shape of them. So training data is 148, 5 columns, and testing data is 50 and 5 columns. That's done. We have completely perfectly created your data and splitted your data in 25-75% format. Okay, so our data is ready to get trained by the algorithm. So here I have chosen a k neighbors classifier. So k neighbors classifier is we have seen already how it performs the operations. We can choose any others also. We can choose decision tree, random forest, we can choose the new Bayes, we can choose SVM also. Logistic regression, that can also be chosen. Even we can choose ensemble techniques also. We can choose bagging classifier, we can choose boosting classifiers, we can choose voting classifier as per the convenience. When the reasonable accuracy is not achieved, that time we are going to make use of this techniques also here. So this is very deep concept where you are going to make use of the classifiers. Here I am using the k neighbors classifier, and to identify how many perfect values present, hypertuning a parameter, that can also be done with the help of the grid search cross validation, which we already seen in the cross validation example, cross validation video. Here I have chosen the number of neighbors 5. Okay, so how many neighbors we require? So I just chosen the number of neighbors equal to 5, and my object is created. So whatever all operations are done, my data is now perfectly available for to get classified, to get trained with the algorithm. Number of neighbors 5. Let's fit. Okay, so the algorithm is fitted on X train, Y train. Okay, and then we are going to do the predictions. These are the predictions out of it. 1, 2, 3. Okay, that's done. So here any one of this classifier we can apply. Just can try that which is giving highest accuracy to you, and based on that we decide the algorithm to get used for this kind of the data set here. Okay, so my algorithm has done the predictions. Now let's see the confusion matrix. Okay, import it and print it. Oh, that's it. Check it out now. This is actual result we require for a project. Here I am not having any misclassified samples. A perfect classification of all the samples are done, and if you see the classification report, check this out. Yes, all are 100%. Precision, recall, F1 score, everyone is 100%, and perfectly we got this classification done with 100% accuracy. See this. This is achievable. Remember the task that we have seen already: outlier detection, resampling, or correlation techniques, or you're finding the cross validation. So this should be perfectly done, so then only we can achieve the 100% accuracy. Also almost all data set is possible to achieve. We can find your feature perfectly, we can perform operation with the help of an algorithm so much perfectly by trial and error, and then by which we can identify the reasonable accuracy. We just try this by removing few of the steps above. How much accuracy you are achieving out of it, that can be identified. So this is how we are going to build the model. We are going to find this model is perfectly built for us. It may be possible that somewhere we are not getting this result correctly, so you need to adjust the data, you need to adjust your pre-processing steps accordingly, and based on that you can achieve reasonable accuracy for your data set. So it is expected that whenever actual industrial projects are deployed, we must be having 100% accuracy for this kind of the systems. Okay, so your classifier is created, we have achieved the 100% accuracy for this particular project. Okay, so it's done there. Now let's save the model. So here I am going to save the model. Output file is equal to wine.model, then sklearn's external context job lib, which can dump this particular classifier into a file, a binary file, output file. Okay, it will dump this. Okay, and scalar also we are going to save it. I'll just show you, which you already seen this two, scalar.model and wine.model. Okay, so we are dumped both of these particular files, because now when you're deploying the project actually on the client side, that time we don't require this project, we require a perfectly trained classifier. Even we can create such a project that algorithm will get trained after every 7 days. That's also possible, that we can make use of, or after 10 days, 15 days, or 30 days like. But here I am statically creating this particular object of the machine learning classifier. And then let's see one simple application. One more thing, when you're done the scaling, scalar model is also expected, because while prediction of the data importing is done in actual values, but prediction require the data to get scaled, because while training we have scaled the data, so while prediction also scaling is expected. That's why we are going to save this scalar model. Okay, now let's have simple prediction of it. So simple, for example, now one more important thing is that only 5 features I have taken, and there are 5 features random value I have given here, and I am doing the prediction of it. So once the prediction, I am transform the data, and when doing the prediction, check this, this is class number 3 predicted by the algorithm. So in this from the data set itself I have taken these values. So we have predicted that this is class number 3. You can change all these values and try for class number 1, class number 2 also, will get the perfect result, because accuracy for my algorithm is 100%. So this is how we build the model. Now remember, our 50% task is completed only. When we actually deploy to the system, deployment will require different platforms. Maybe we require a desktop platform, maybe we require a web-based application platform. As per the requirement, we can make use of it. So whatever tasks we have done, all they are dumped into this wine.model, okay, and scalar.model. Scalar is supplementary thing, wine.model is very important thing, which is present into binary format here. Okay, so whatever is done inside it, whatever features are taken, whatever algorithm is used, this is not visible to the general user. Okay, that's why. So simple operations, these are done. So file is shared with you. Tasks we can do by your own. Why and how they are done, that is already explained in the previous videos. Now let's go for the graphical user interface design. So there are multiple ways by which you design your GUI, maybe by using your application of web can be done, or we can make use of the tkinter. Tkinter we already seen. So here in this I am using a tkinter application to design a GUI for this. Just consider that I am going to have a system where the wine qualities are extracted by a machine. These properties are extracted by machine, and that machine is having a GUI which you have developed, and it will take that all 5 properties only out of 13, only 5 properties extracted by feature selection, we have seen that, and that will predict what kind of the class that wine is containing. So this is my project which I have designed in Python. So let's see how the GUI is designed, and we'll go for simple application of this. So I'm importing tkinter libraries, which is expected. Then this is most important, from the Jupyter notebook I have dumped my models, my objects, so which are dumped there. We just have to copy this in with this particular project, and I'm reading this again. I'm loading classifier is equal to joblib.load wine.model, and scalar is equal to joblib.load scalar.model. So they are dumped and they are now loaded into actual deployed project. Okay, so even web application deployed, there also we can use in the same ways. Okay, now create w.tkinter. This is title, wine quality categorization system. Your GUI will contain this title. Geometry 500 pixel, 500 width by 500 height of that top is given. Resizable. Okay, I'm not going to resize this particular window. I'm keeping it 0 0. Okay, now this task I have done to keep my window at the central position. Okay, this is what tkinter will suggest us. Screen width and windows width and height I am taken, and based on that x and y coordinate are considered, and based on this I am using geometry, where fixed format of window height, window width, x coordinate and y coordinate is given, and we'll have this data at fixed position there. Okay, so simply that's done there. Now on my GUI I am going to design. Okay, I'll show the output of this program first, and then we'll go for the designs. See this. Okay, let's run. You can use any ID, anything which will run your Python program. So here I am using this project. See the GUI first, and then I'll explain how exactly it was designed. Okay, see this. This is wine quality detection system. This is created. 5 properties which are extracted, features that we are extracted, only that input I will be taking over here. Okay, alkalinity of ash, then magnesium, flavonoids, color intensity, and proline. When you want to check, so it will check what kind of wine is this, class number 1, class 2 or class 3. Okay, so just look at the system, the GUI. I'll show how it is exactly designed. Okay, this is the title, this is the label which is I have given there. Okay, so this is a label. See this one, wine quality detection system, font and placement also I have created there. Even second label, alkalinity of ash, their font, their placement. Okay, so this is what we require. Font courier 16, and a placement is from x side 20 pixels, from y side 100 pixels. Below to that we have in front of that we have a text box, that is entry box. Okay, so whatever we are entering into this entry box, I am storing in the variable a, this variable a. So a for alkalinity, m for magnesium, then f for flavonoids, c for color intensity, and p for a proline. Okay, so they are taken, and in that variable whatever you are entering into this text box, I'll be storing into this variable there. Okay, then font placement, this is designed completely, and accordingly that I have just chosen, means from x side, y side, x y for everyone. For this entry points also x and y, these points are chosen. If you go to flavonoids, this one, this entry box for flavonoids, check it out. This entry box of flavonoids contains the font courier 16, and placement is 280 and 200, means from this side is 280 and from above it is 200 pixels. Okay, so we have designed the GUI already, so the same method, mechanism, methodology is used over here. Okay, so 5 labels and 5 entries. Below to that we have a button present there, this one, which contains the name check, font courier 16 bold, command is check. Command is check means when you click on this button, the check function will be called above, which is present above. Okay, so it means that when you click on this check button, then only classifier should get loaded, and then prediction should be done. Okay, so in this way we have done that one. Now this is how I add the image of wine. You can see this wine image, so PNG image present there, downloaded from the net, and then I have placed that at 550 to 100 position there. Okay, okay, so this is how the design of GUI is done. And if you go to check, when I click on the check command here on check command, then we'll go to perform these operations here just mentioned. Okay, so A, M, F, C and P, these values I am entering from the entry boxes. these variables are declared here, that's why I made global over here. So this variable will accessed here. Okay, FCP. So this value I'll read. So when I enter this data here, I'll click on check. So when I click on check, this statement will be executed. So I'll be reading the value from A, M, F, C and P, which names are given here, A, M, F, C and P as a text variable to the entry boxes. All they are combined together in an array format. Okay, I'll print that, check that whether the data entered is correct or not, which is not expected actually, but just for verification I have used this. Then this loaded classifier, okay, which I have dumped, I have imported here in this. Okay, so that I am using here now, classifier.predict. Whatever data I am having, that I will transform it and then I will predict in ypred. So three possibilities are there that ypred will give us: class number 1, class number 2, class number 3. So when it is ypred 0 is equal to 1, so use message box to show info result as this is quality 1 wine. If it is 2, quality 2 wine. If it is 3, quality 3 wine. So in this way, three different qualities of the wine will be predicted from this particular button or this particular function, check. So this is the way we design the GUI, graphical user interface. Here, see, classifier and scalar task is for this line only. And to have this line, we have done all of these pre-processing steps to deploy your machine learning logic. We have done the predictions, and now we are going to make use of this prediction to identify the qualities of the wine, quality 1, quality 2 or quality 3. Okay, so this is how we design the project, and almost all things are done there. And if you go to check the quality of the wine now, so this is wine quality identification, which will be useful for the wine producers, and they will identify what quality of the wine is there based on all these 5 properties. So let's have this property and check the qualities of the wine, they are working correctly or not. Okay, so let's have some random values present here. Okay, I need to use one of the random values. Let's see this 9 number, which is quality 1 wine actually. So alkalinity is how much is that? That is 17.6. okay, magnesium is 121, flavonoids is 2.51, color intensity is 5.05, and proline is 295. Okay, this is quality 1 wine actually. So let's check it. Okay, so it's difficult to take these values from CSV file directly, so I'm taking these values, okay, check it out, from 32 number for example. Okay, so let's see, from 32 numbers row I'm giving these values. So I'm giving alkalinity of ash is 17.20, magnesium is 1, then flavonoids is 2.69, color intensity is 3.84, fluorine is 990, its class is 1 actually. So let's check it out. Okay, this is quality 1 wine. Okay, so just an random values are extracted. So let's see one more random value, for example number 132, it's class 3 wine, and let's add these values and check whether it's predicting correctly or not. Any other values can also be possible, but I'm taking directly from the data set here. So 24.0, magnesium is 3.0, then flavonoids are 1.09, then color intensity is 5.70 and proline is 560. Okay, so let's check this. Okay, so this is quality 3 wine extracted. Okay, in this way we are going to make a development of the project using the data science combinations and Python, GUI design, everything. Many things are possible in this, but I have shown this in the most simplified way, how exactly we are going to build the classifier, how it will help us to predict the things without using any data. Now see, if you consider this particular project, it's very simple, clean and clear project of 62 lines only. But before that, I have done the pre-processing identification of this classifier, this wine.model, for almost more than 125 lines over there. So this is the efforts that we required behind it. We don't have any communication mechanism like if else rules or nothing is present. only the object is present which will define your prediction system. So this prediction system can be infinite, we can make it infinite, we can deploy it anywhere, we can connect it to any other systems also. So it depends upon your application, how do we apply that particular to your system. So this is how the project designs are possible. Many projects are available, many problem statements are available online, some will be given by us also. We just can use your knowledge, whatever you have learned in this whole course, you can apply, you can implement, you can use this particular knowledge as per for requirement for design of a data science project wherever required, and wherever it's beneficial, where it's useful, we can make use of it. The communication mechanism with us is also already shared with you. This course, this data set, and both of these programs will also be shared with you. Just try practice, try and practice the things, use multiple things, search the thing, research the things, and try to learn the data science in all the dimensions. Okay, that's from our side. All the best. Thank you. Thanks a lot.